We're going to take a look at word problems that result from a standard form style equation of a line. And you remember standard form is ax plus by equals c. So these are scenarios where when you write the equation to represent the scenario, it's going to turn out to be in that form. This blank sheet is available for you on the lesson plans, as well as the completed sheet. It would be very smart for you to have access to this as we go through the video. So to begin with, I would like you to read that scenario and think about the equation that you would write to represent what's going on. And if you need to pause the video to do this, that would also be a smart move, because if you don't read this and understand what's going on, the rest of this sheet is senseless. So here's my equation. I end up with 2 hours of work for every bench, 6 hours of work for every table, and I have 60 hours in total available. So there's my equation, and since we're working with standard form, a lot of times people would prefer to turn this and this into x's and y's, and that's totally fine. Everything from here now is going to be things you're familiar with these equations. For example, if I wanted to find the x and the y intercepts, I just start my t-chart and I say every x-intercept has a y value of 0, plug in a 0 for t or for y, and I get out my 30. Same thing here. Now I can get both my intercepts. This should be something you're familiar with from working with these equations before. And we could take this equation or this equation and solve for y. Or we could take this one and solve for t, because the t is acting like the y in those equations. So now by doing that, we have y equals mx plus b. I see a slope, I see an intercept. Or I see a slope and I see an intercept. Here we're just using t's and b's instead of y's and x's. So now you can graph this. It's probably easiest to graph this when you're using the intercepts. 30, 0, that's a point on the graph. 0, 10, that's a point on the graph. And we have our y-intercept and we have our x-intercept. I messed up that order. We have the x-intercept, that's where the graph intercepts the x-axis. We have the y-intercept, that's where the graph intercepts the y-axis. So we could put some coordinates on here. For example, that is 0, 10. This is 30, 0. And there's a problem later on down on this worksheet that tells us that this point is 6, 8. So far, the only thing new is you have to be able to read a situation and build an equation to represent the situation. We've been doing that throughout the year. But finding intercepts, solving for y, making a graph, all of that is your regular old standard review stuff. And in fact, finding a domain and a range is also review stuff. This graph spans x values as small as 0 and up to 30, and the y values go as small as 0 and up to 10. So we're writing the domain and range just like normal. Now we're going to take a look at what the ordered pair 6, 8 represents. There's the ordered pair 6, 8. And remember that could represent an x and a y. Or in this scenario, and this one's the tougher to keep straight, this could represent a b or a t, which is the number of benches you've made and the number of tables you've made. So you can sometimes help yourself if you label the axes quite well. The x-axis is for benches, the y-axis is for tables. So when you see an x-coordinate and a y-coordinate, you can use benches for x, tables for y. But what this ordered pair ends up meaning is we have made 6 benches and 8 tables. So that ordered pair has meaning. And basically you could also look at it this way. This is at the location of 6 on the x-axis and 8 on the y-axis. Now there's a bunch of ordered pairs going down this graph which show all the possibilities of different combination of benches and tables that you could make. This very last question asks if a woodwork maker decides to make 14 benches, how many tables can he make? Before we do the math on that, I'm going to show you what that would look like on the graph. Okay, now this won't be perfect because our graph's not perfect, but 14 benches seems to be about right here. That's about my 14. So if I head over here, it looks like around 6 tables, but I don't really trust that for sure. I'm going to do the math to find out exactly. And I can just say 14 benches take 2 hours each, so I use up 28 hours. Well, I have 60 hours in total, so 60 hours in total minus the 28 I used on my benches means 32 hours remaining to work on tables. Tables take 6 hours each, so 32 divided by 6 is 5.333. Nobody wants a third of a table, so I can get a maximum of 5 tables if I've already made 14 benches. So my estimate using the graph was about 6 or a little over 5, and then when I do the exact math, it's 5. Everything we've done here is kind of review of things we've been doing with lines before, and the one new step, which we've done earlier in the year, is read a scenario, make an equation that represents the scenario. You can either use variables that make sense in the scenario or go to the old x and y that we've been used to for graphing.